Welcome one, welcome all for Lab 3. We have here. Wonderful, wonderful time we have with Lab 3, black hole orbits. We got some great computational models going. We glow scripted some things. We glow scripted two things. One was to demonstrate the forces during an orbit, and the one was to demonstrate like the more complex, like specific details of an orbit with like all the forces acting each other, getting it to all work out to make a stable orbit. We were doing this lab to demonstrate like centripetal forces, gravity, general spinny orb things, Uh, Primary equation we used, we got like position update, velocity update, F equals ma, gravitational force. Y'all know the drill. We got some great pictures from our lab here. Each equation and their respective code, right? So we got like the force arrows being demonstrated here, which was wonderful. I think there's some direction in that one as well. And then it never crashed, which was the rule for that other one. Very, very challenging project that was, getting that to work properly. Error. Um, Eventually, in the one with the stable orbit, in my code, it does just eventually reach escape velocity, which isn't great. I'm not really sure how that happens, but it does that. But I was told it's fine. So, but in general, there's not a lot of strict errors because the wind conditions, like what we were supposed to be doing in the lab, was very clear. There's not a lot of failure points that we were allowed. Uh, in general, we needed so we got some questions to answer, right? Net force and like parallel and perpendicular components compared to the rate of change of momentum. The rate of change of momentum is net force, like by definition. So its parallel and perpendicular component should be the same, but its perpendicular component is like what draws it to the like object that it's orbiting. Like an object that is orbiting, its perpendicular component of force is drawing it towards what it's orbiting, and its parallel component is whether it's speeding up or slowing down in that orbit. Now, if we had an imaginary system with a black hole, star, planet, moon, wanted to predict the motion of the entire system, we would have to calculate the gravitational force between all of the objects and how that affects all their things, creating a very interesting, very difficult to process net force. I mean, it's possible, but it's just a lot. Would there be any dominant interactions? Obviously, the black hole star, like the black hole, assuming a large mass black hole, would be dominant to the star, dominant to the star would be dominant to the planet, planet dominant to the moon. Um, in general, the moon would orbit the planet would orbit the star would orbit the black hole. If it's at galaxy scale, black hole is like, I mean, these are really all just masses. I mean, between planet and moon, you got a good idea of the mass relativity, but not between black hole and star, which is kind of annoying. But in general, you just map each gravitational to itself. Very useful lab. Learned a lot about how perpendicular forces work, gravitation. Great time overall.